Hi there, today I'm going to show you a new model of the atom. I'm also going to show you what neutrinos are, and hopefully I might answer a question or two on the way. Right, basically this is the current model. We see on the Big Bang Theory, you see the fuse or kind of central core there with the electrons flying around the edges. But then that doesn't make sense to me, because you just have to break it down to one simple thought. And that's, in order for the universe to stay bonded, each different state would have to have different states of laws of attraction and repulsion. Because if everything just attracted and everything just repelled, then you wouldn't have three states. You wouldn't be able to. It'd have to be alternating. So you've got your subatomic, like your smallest state. Then you've got the atomic, obviously our state, and then you've got astronomic, obviously the universe. Kind of those three levels basically, and in order to have that sort of three layers of fabric, if you will, you'd have to have alternating laws of attraction and repulsion. And that's why this model doesn't work, because the central core would have to have items in it that repel each other, or attract each other. So like subatomically, opposites repel. Unlike atomically, opposites attract in our sort of state of being. So if you look at this model, you'll see here we have like an outer shell, and I'll tell you what this is in a bit. Inside we have antimatter, and that antimatter has been stuck in there since the dawn of time, and these have been whizzing around at the speed of light, trapping it dead in the centre, because they're everywhere at once, all at the same time. So it's completely engulfed in the centre by force, because it repels that. Obviously, if matter and antimatter should touch, they say cataclysmic events, but they have such a repulsion factor that to get them to touch would take hell of a lot of energy and effort. So it's not something that would happen naturally. And basically, so this was how the universe started before the Big Bang, like frog spawn. You've got your positive, you've got your negative, and you've got your neutral, because that's what life is, the three: positive, negative, neutral, solid, liquid, gas. Do you know what I mean? It's pretty much the standard for life. And something happened, boom, like the big release or whatever it is, and these things get displaced, and maybe actually the reaction between antimatter and matter is quite significant in that process, because if one can cause a cataclysmic event which will send rays and matter out into the universe to interact with each other to create what we see today. But yeah, see, it just breaks down to one basic thought. Like, in order for the universe to stay bonded, those three different states would have to have opposing reactions, repulsion and attraction. So now this is what neutrinos are basically. Like I was showing you a second ago, these shells on the outside, when they're voided of their matter, they haven't got any antimatter, they haven't got any fermion boson, whatever you like to call them, the positive, the negative inside them. They shrink down and they have no atomic mass, because they've got nothing inside to react to. So atomic mass is only very, sort of say, an electron would have a pull, and that attraction could be weighed. And that's why these things have no atomic mass, because they've literally got nothing in there to attract with. But they can become different things like protons, neutrons, electrons, whatever. And that's how electrons are created, actually. I'll get to that in a second. But like, say matter gets pulled into the black hole, and it doesn't get squeezed indefinitely. Scientists have discovered that there's actually a beam that comes out the centre, a beam of radiation, and there's also a beam of something coming out the back. Now, if you think of the flow of energy, like as with anything in life, you have a positive and a negative, and you have the same with galaxies. You've got this black hole vector, and here you've got your positive and your negative side of it, and the flow of energy. Basically, when matter gets pulled in, the antimatter inside is released from its bonds, and the repulsion factor experienced between that and matter, at mass, you think how much of it, like a whole solar system getting pulled in, and a whole solar system's worth of matter and antimatter just being like freed from their bonds. the antimatter gets shot out the back to form clouds, and because it's inert, it has no inertia or whatever. It's got no momentum, and your positives, like your fermion and your boson, gets shot out through the other end. Now that is quite an intense beam of radiation, which scientists have witnessed across space, like these big bright flashes. They say it's like with the light of a galaxy, but then if you think about it, from the light we see from the galaxy is only the side that's facing us, and also it's just the surface area that's shining. It's not every single atom inside the actual mass itself. So you think when you're seeing these beams, if whole solar system's worth of atoms are all being shot in your direction all at the same time, and it's not just the surface area, it's going to appear like it's a galaxy's worth, and that's what's got them baffled. There's a few things that got them baffled. Another one is they reckon that all the antimatter in the universe has disappeared, but as matter can't be destroyed, it can only be transformed. You know, it must exist somewhere in another state, and that's where it is. It's actually still inside all of matter. So it's just trapped in there since the dawn of time by these things whizzing around. Yeah, so it's got to be hard to separate it, because if you get a collision, of course, then it's yeah, game over. But so that's what's going on here. See, when's all this energy's free, the the antimatter, the matter out the top end and your antimatter out the bottom end, but then your neutrinos are shrunken down and they've got no atomic mass anymore, and they shrink down to tiny little sizes. They've got nothing in them, and they just float through space around this habitable area, like the equilibrium where all the planets are. And yeah, and then the way they react, well, I'll explain that in a second actually, the way they react with the universe and what their true purpose is, if you can call it that. I mean, it does look like there's rhyme and reason. But yeah, so different ways to think about it, you know, matter, antimatter, and neutrino, positive, negative, neutral, or fermion and boson, and antimatter. But either way you look at it, it's always the positive, the negative, and the neutral. I think that's pretty much like a standard plan of life. So this is the way neutrinos work, right? So now they've been chucked out of like they've been voided of their content, sorry, by the black hole, and they've wandered into some just some mass. I'm trying to think of the word. Oh, yeah, they wander in the presence of matter. Sorry, that's what I'm trying to think of. They wander in the presence of matter. Once they've vibrated, so they've resonated, influenced by waves which knock them about. See, it knocks all the little bits out of their shells, because usually they're spinning around the inside, and this shell doesn't need any force at all, because they're literally spinning. They're getting guided around it. But normally they would just keep going around and they won't be able to escape it because of the way they're spinning. But if they're shaken, they can get knocked out of that shell, and then they could be re-rubbed by the same process into passing neutrinos, therefore filling them up. And this is how frictional energy creates electrons. Just kind of rubs them into them, you know. So then you get the bosons will get rubbed into the other, which is less likely, because I guess like that we've got no. Mind you, I don't know if it's less likely. But anyway, like yeah, and then like where it's less likely, or even more less likely, is for them positive and negative to enter the same shell, because they repel each other. It takes some force to do that. So then they're called neutron. No, I can't remember. Yeah, yeah. Can't remember. Anyway, so like say you've got a fire here, right? And all these particles are being displaced. They're all out of their shells because they're being decayed by the fire. So as they're all going up, because they come to the smallest parts of the atmosphere, like in water, a bubble will rise straight to the top. These become the smallest part of value quantity in the atmosphere, so they shoot right up quick. But as all the waves are going up, they're resonating all the atoms in the atmosphere above the fire, and this rubbing effect actually rubs the particles that are being displaced from the logs and burning logs back into passing neutrinos. They then cling to atoms as electrons, and then they equally dissipate themselves. And the reason for that is there's always going to be equal parts that there is inside here as there is outside there. And that's why an atom will always equalise itself. It's not through intelligence, it's just through you know, the laws of attraction and repulsion. And this stuff's voided from, like I said, this frog spawn sort of stuff from way back when. Its value's already been predetermined, so like unless there's a big event that will change its value, it will kind of stay like that. It will take on electrons, it will give off electrons, but it will stay like that. But yeah, see, there's a lot going on with resonation. It's like the key to understanding the universe, you know. It's the cure for cancer. It's yeah, just by like resonating the mutated cells, and by their very nature, they'll be fallible, so they'd fall apart and leave the healthy cells because they're used to a degree of resonation from waves from the sun and whatnot, and they are home to perfection over millions of years. And the body just recognises those broken cells as being malformed, I guess, and readjusts. And there's been numerous doctors that have actually been documented curing cancer that way. And it's just a shame it's being hidden in the name of profit. And people won't believe it. You know, so when it's something that simple as well, you do think we'd be told, wouldn't we? They wouldn't let us. But when you think it's reportedly, this last one I saw on TV was £500,000 a course. Well, I think it might even actually been £1 million. Yeah, it's tragic, really. But there you go. I mean, this yeah, basically this answers quite a few questions. Oh yeah, there we go. Forgot about this. Scientists have built a study right down underneath the surface of the Earth because they're saying there's less neutrinos down there, so it's easier for them to study, which means that neutrinos can't permeate down to the core, which proves my point that they can't contain the hemothermic reaction, like the nuclear fission that's going on there, and because they can't come in to control it, to get these particles to get resonated into those, they get destroyed. So it's always going to stay like this nuclear fission. But if they could permeate right down and they could control the reaction there, you know, that's the Earth would go cold, I guess. But it's the same with the sun, you know. It's like they say it's you know, it's for hydrogen, but it's only because it looks like it's for the hydrogen. Hydrogen's a highly combustible material, and to think that something's made of a big ball of it's made of a highly combustible material, and it's been burning for a long time, just doesn't make sense to me. But it's only just got one what's it called, circulating it. I think it was one electron or something, or one proton, one of the two. But hydrogen only has one electron, I think, and that's why it looks like it is, because it's just all fermion. It's all just like one big ball of fermions all swimming around, which they haven't shooting around causing thermic reactions, and that they can't be contained because of the what's its faces can't get near it, the neutrinos, because it's trained to keep them out, but it's also trained to keep them in, but it's also trained to keep them out as well. So when these particles are coming off the sun and hitting it, it's actually like pushing the neutrinos away, so they can't contain the reaction. And that's basically what they are. They're to stop the universe from going into fission. That seems to be their and if anything, the universe just seems to be like we're inside something else, like the babushka doll, you know, like the grandmother dolls, one inside the other, that's the dolls. And that's each one completely oblivious to what they're a part of. And I think that's probably what's going on here with us, really. The Big Bang is the birth, the egg, and then it just keeps on going until it dies and turns to gas. Yep, and that's where the universe is going. But yeah, hope you enjoyed this video, or these videos I think it's gone into now. And leave any comments if you've got any. Nice one, cheers.